Hey everyone, welcome. Today we are diving into one of the most important, one of the most fundamental ways to write the equation of a line, what we call standard form. And I promise, by the end of this, you'll be able to handle it like a pro.
So, here's our game plan. We're going to start with what standard form actually is. Then we'll get into the nitty-gritty, the specific rules you absolutely have to follow. After that, I'll walk you through the conversion steps, we'll do some examples together, and then, it's going to be your turn to solve one. Let's get right into it.
All right, first things first, what in the world is standard form? Let's lay down the foundation here.
And here it is. This is the classic look. AX plus BY equals C. This is the core structure we're aiming for. Now, A, B, and C, they're just our coefficients and a constant. But here's the catch, and it's a big one. They must be integers. That means no fractions, no decimals. We're talking clean, whole numbers.
You know, this right here is what makes standard form such a game changer. It doesn't matter what an equation looks like to start with. It could be in slope-intercept form, point-slope form, whatever. You can always rewrite it into this standard format. It's kind of like the universal language for straight lines.
But to get this just right, to be in what we call true standard form, an equation has to play by a few very specific rules. And these aren't just suggestions, they're mandatory. So let's see what they are.
Okay, so here are the four non-negotiables. First, like we said, A, B, and C have to be integers. This is all about keeping the equation looking clean and simple. Second, and this is a big one people forget, that A value, the number in front of the X, has got to be positive. It's a rule that just keeps everything consistent. And finally, the setup. You group your X and Y terms on one side, and you push the plain old number, the constant, to the other side. That structure is what makes it so useful.
And this slide just lays it out crystal clear. See on the left? 2x plus 3y equals 7. It checks every single box. All integers, and the a value, 2, is positive. Perfect. Now, look at the right. These are the common mistakes. The first one has a negative a. Nope, not allowed. The second one has a fraction. That breaks the integer rule. And the third one, full of decimals. Also a no.
All right, so that's the goal. But how do we actually get there? How do we take an equation that's not in standard form and whip it into shape? Well, it turns out it's a pretty straightforward three-step recipe. So it really just boils down to these three things. Step 1, get rid of any fractions. Standard form doesn't like them, so you just multiply the entire equation to clear them out. Step 2, get organized. You need to group your variables, so move the x and y terms to one side and the constants to the other. And step 3, the final check. Look at your a value. If it's negative, no big deal, just multiply the whole equation by -1 to flip the sign.
Okay, theory is one thing, right? But let's actually get our hands dirty and see how this works in practice. This is where it really starts to click. Okay, for our first example, we've got a pretty common sight, an equation in slope-intercept form. And right away, you can probably spot the problem, can't you? That fraction.
All right, let's just follow our process. Step 1, that fraction has got to go. To get rid of that 5 in the denominator, we multiply the entire equation by 5. That leaves us with 5y equals negative 2x plus 35. So far, so good. Step 2, group the variables. We need that x term on the left, so let's add 2x to both sides. Now we have 2x plus 5y equals 35. And finally, step 3, the final check. Is a positive? Well, it's 2, so yes, we are done. That's our final answer.
Okay, ready to level up? What happens when you don't even have an equation to start with? What if all you have are 2 points on a line? Don't worry, it just means we have a little prep work to do at the beginning. First things first, we need an equation. So we start by finding the slope between those 2 points, which, if you run the numbers, comes out to a nice clean 4. Now, here's a little trick. Notice the point 0, -7? That's the y-intercept. That saves us a ton of work. We can just jump straight to slope-intercept form, y equals 4x minus 7. And from here, it's the same process we just learned. We move the 4x over by subtracting it, which gives us negative 4x plus y equals -7. But hold on, we're not done yet. Look at that a value. It's negative. So for our last step, we multiply the whole thing by -1. That flips all the signs and gives us our beautiful final answer, 4x minus y equals 7. All right, so you've seen me do it a couple of times. You know the rules, you know the process. Now, it's your turn. Let's see what you've got. Here we go. Your mission, should you choose to accept it, is to get this equation into standard form. Go ahead and hit pause, work through those 3 steps we covered, and we'll check in on the other side.
So how'd you do? The correct standard form is 3x plus 5y equals -10. If you got that, fantastic work. You probably started by multiplying the whole equation by 5 to knock out that fraction, and then just added the 3x to move it over to the left side.
And that wraps up our look at standard form. Really, the big takeaway here is that by having this one consistent look for every line, this ax plus by equals c format, it makes them so much easier to work with and compare. It just simplifies the whole process. So that leaves us with a bigger question, right? What other things in math have a standard form? And why is that consistency so incredibly important? Something to think about. Thanks so much for watching.